Welcome to This Explainer. Today, we're going to unpack something absolutely vital that's happening inside your body right this very second. I'm super excited to guide you through this because, well, it fundamentally connects every single one of us. But before we even look at the data, let's do a quick visceral biology experiment together. Ready? Wherever you are, just stop for a second. Now, take a deep breath in and let it out. Okay, let's dive into this. That simple, kind of unconscious action you just took, it actually kicked off an incredibly complex, highly synchronized process. Your respiratory system literally just sprang into action to do its main job, bringing fresh oxygen in and booting carbon dioxide, which is basically cellular waste, right out. It works in absolute perfect tandem with your circulatory system to deliver that oxygen to your tissues and carry the waste back. It's just a continuous, life-sustaining loop.
Part 1. Gateway to the lungs.
So let's follow our air molecule protagonist as it enters the upper respiratory tract. First stop, the nose and nasal cavity. Now this isn't just an open door, right? It's a full-on processing center. Hairs and mucus filter out the dust, while the cavity itself warms and moistens the air so it's prepped for the delicate tissues up ahead. Next, the air travels down the pharynx, your throat, which is actually a shared pathway for both breathing and eating. Finally, it hits the larynx or your voice box, and this right here brilliantly shows off the body's intelligent design. The larynx contains the epiglottis, which is this crucial little flap that acts like a tiny traffic cop. It snaps shut when you swallow to absolutely prevent food or water from going down your airway. Part 2. Into the lower tract. All right, the air now plunges into the lower respiratory tract through the trachea, the windpipe. Think of this as the main highway down to your lungs. It's a really robust tube, and it's kept wide open by these rigid, C-shaped cartilage rings. But it's not just a pipe. It's lined with sticky mucus and microscopic hair-like structures called cilia. These cilia act like tiny little brooms, literally constantly sweeping trapped particles and microscopic invaders back up and away from your lungs. It's an absolutely brilliant, built-in defense mechanism working for you around the clock.
Now, what's really interesting about this slide is a fascinating quirk of our anatomy. You see, the trachea divides into the right and left bronchi, leading into our two lungs, which are safely wrapped up in a protective membrane called the pleura. But here's the thing. They aren't identical twins. While your right lung is larger and has 3 distinct lobes, your left lung is slightly smaller and only has 2. Why? Well, because it literally has to leave a parking space in your chest cavity for your heart. How wild is that?
Part 3. The mechanics of breathing. Now let's talk about how the pump actually works. Breathing relies on 2 physical phases, inhalation and exhalation. And the absolute star of this show is the diaphragm. It's this dome-shaped muscle sitting right below your lungs. During inhalation, the diaphragm contracts and flattens downward, while your rib muscles expand the chest cavity. This extra space causes the air pressure inside your lungs to drop, creating a vacuum that literally pulls air in from the outside. Then, for exhalation, the diaphragm just relaxes and curves back up. Your chest cavity shrinks, the pressure rises, and the air is pushed right back out. Without the diaphragm driving this automated biological engine, well, normal breathing would be incredibly difficult. Part 4. The magic of gas exchange. And here we are. We've arrived at the alveoli. This is the ultimate destination for our breath of air. They are tiny, incredibly thin-walled air sacs, and your lungs are absolutely packed with hundreds of millions of them. They create a massive surface area. Seriously, to put that into perspective, if you were to flatten all your alveoli out, they'd cover an entire tennis court. Each one of these microscopic sacs is tightly wrapped in a web of tiny blood vessels called capillaries. This intimate little meeting point between the air and your blood is the most critical site in your entire respiratory system. So, the crucial point is how the actual swap happens. It all comes down to a process called diffusion. The fresh air inside the alveoli has a high concentration of oxygen, so that oxygen naturally just diffuses across those super thin walls directly into the blood, where most of it quickly binds to hemoglobin in your red blood cells. At the exact same time, the blood arriving at the lungs has a high concentration of carbon dioxide, that cellular waste we talked about earlier. The carbon dioxide diffuses out of the blood into the alveoli, and boom, it's ready to be exhaled. It's just a rapid-fire, life-giving exchange. Now, speaking of carbon dioxide, its return commute is actually a bit more resourceful. See, oxygen relies almost entirely on hemoglobin for a ride, but carbon dioxide takes a few different paths. A small amount just dissolves directly in the blood plasma, and some binds to hemoglobin, sure. But the vast majority travels safely by being converted into bicarbonate ions. And this clever little chemical conversion is absolutely vital because it actually helps regulate your blood's pH, maintaining your body's delicate acid-base balance along the way.
Part 5. Protecting your vital engine.
Now, obviously, the respiratory system comes fully loaded with a multi-layered defense strategy. You've got physical barriers right at the door, like nasal hairs and sticky mucus trapping particles. You've got those microscopic cilia we mentioned, constantly sweeping debris upward. You have powerful mechanical reflexes, like coughing and sneezing, to aggressively eject irritants. And hey, if microbes actually do manage to reach the deepest parts of your lungs, you have dedicated immune cells patrolling the alveoli to neutralize infections. It is a seriously incredible security system. However, when these defenses are overwhelmed, compromised, or repeatedly exposed to irritants, common respiratory diseases can take hold. Conditions like asthma narrow and inflame the airways. Bronchitis, as the name suggests, is an inflammation of the bronchi. Pneumonia and tuberculosis are severe infections. Pneumonia actually causes the alveoli to fill with fluid, while TB is a specific bacterial threat. We also see conditions heavily linked to environmental factors and things like smoking, such as chronic obstructive pulmonary disease, or COPD, and the abnormal cellular growth that leads to lung cancer. Because the system is so vital, actively maintaining its health is totally non-negotiable. First and foremost, avoid smoking and vaping. Those directly damage the sweeping cilia and your alveolar walls. Exercise regularly. That keeps your respiratory muscles nice and strong. Eat healthy foods and stay hydrated, because hydration keeps that protective mucus at the exact right consistency. And finally, minimize your exposure to polluted air, practice good hygiene, and get your vaccinations to give your immune cells a real fighting chance against respiratory infections. Every single day, you take thousands upon thousands of breaths, probably without even a second thought. But from the warming pathways of your nasal cavity all the way down to the microscopic rapid-fire gas exchange in your alveoli, it is an astonishing journey. So, as you go about your day and take your next breath, will you appreciate the complex, automated, invisible engine working flawlessly inside your chest? I really hope this explainer has given you a newfound respect for the vital mechanics of human respiration. Thanks for exploring this with me today, and hey, keep asking questions about the incredible biology that makes you, you.